Hello everybody, welcome back to Math 2413, more on math. Today we're going to talk about Chapter 3, Section 8, mostly dealing with logarithms and converting to logs. So here's a review, what logarithms look like, but the derivatives. Y equals ln x, natural log of x. The derivative is 1 over x. Whatever's here goes on the bottom. Y equals ln u, where u is a function of x. The derivative is the derivative of the u part divided by u. Now, that's with ln's. Now, with logarithms, with base, whatever else, the derivative is simply 1 over x, whatever this function is here, a, ln a. What that came from is this, using the logarithmic conversion principles. If you don't have log base 10 or log base e, you can't use a calculator for this, so you have to do change of base. The change of base is like this. Whatever's here goes on top, whatever the base is goes on the bottom. So this is the same. That's a constant. This is a number. So that stays where it is. Nothing happens to that one. But the derivative of ln x is 1 over x times n of there. So likewise, if I had log base a of some function, then there'd be some ln of some function over ln a. So the derivative would be du u ln a. The derivative, whatever this part is, over whatever that is, times ln a. Alright, let's look at this thing. Homework problems. Let f of x equals negative 7 over 8 x plus 7. Find the inverse function, graph them on the same graph. I'm going to pick which one of these three, and then evaluate the derivatives of them. So, let's get scratch paper. No. 3, 8, 1. That's the same thing as y equals negative 7 over 8 x plus 7. The way you find the inverse, this means inverse. First, switch x and y. To solve for y. So I'm going to get rid of that one first. So subtract 7 from both sides. So x minus 7 equals get rid of the denominator. So I multiply both sides by 8. So I have 8x minus 56. The 8 over here cancels, so it's equal to negative 7y. Change the signs across the board. I'm going to change that, change that, change that, and divide by 7. So my inverse now, that's what this finds. Once I solve for y, it is now my inverse. That's my inverse. So it's negative 8 over 7x plus 56 divided by 7 is 8. So the original function was negative 7 over 8x plus 7. And the inverse function is negative 8 over 7 plus 8. So when we ask so we have here negative 8 over 7x plus 8. We look at both of these functions, we're supposed to graph them. Well, we know that the y-intercepts are in positive for both of them. So out of that's not it, so y-intercepts, nope. The only one that have y-intercepts there are those. And they both have negative slopes. So A is the graph. Now we take the derivatives. If we take the derivative of the first function, we get negative 7 over 8. If we take the derivative of the second one, we get negative 8 over 7. So that's the first one. Number 2 is the same. So same as number 1. So you did it already. Now find the derivative with respect to x. So here's our function. Let me write that down. 3, 8, 2. So we have y equals ln 7x plus 2x. No, it's 3. Yeah, it's 3. So we're supposed to find the derivative of this function. Since it's two separate parts, the derivative of ln, we just on another sheet, since here's a function, ln u is du over u. So the derivative of 7x is 7 over 7x. Derivative of 2x is 2. The 7's cancel, so I have 1 over x plus 2. So that's that derivative. Where's my sheet? There it is. So the answer is 1 over x plus 2. Number 4. Y equals ln x to the power 13. Okay, the rule of logarithms is anytime you have an exponent, they come out to the front. So the derivative, that's the leading coefficient, the derivative of ln x, derivative of x is 1 over x. So it's 13 over x. So it's 13 over x. Okay. Let's look at the second page. Okay, number 5. It's a quotient rule, so I'm going to use paper. Y equals ln 13x over 13x. So this is F, this is G. So ln 13x. So the first derivative is 13 over 13x. So this one is 1 over x. So the first derivative is 1 over x times 13x. Since it's division and subtraction, 13 times ln 13x all over 13x squared. So we have here the third x here and the x here cancels. We have 13 minus 13 ln 13x over 13x squared. Okay, on top I can take out a 13. 1 minus ln 13x. And the bottom I have 13 squared x squared. Gets rid of one of them. 1 minus ln 13x over 13x squared. And that's that answer. That was number 5. 1 minus ln 13x over 13x squared. Alright, the next one, number 6. Find the derivative of y equals 9 ln of 5 ln x. Here it goes down. 3, 8, 6. Y equals 9 ln of 5 ln x. Find the derivative. So I said leading coefficient. So the derivative of ln is the derivative of the inside all over what's inside there. So the derivative of the inside is 5 times 1 over x okay. So it's 9 times 5 over x, 5 ln x over 1, 9 times 5 over x, 1, 5 ln x, the 5's cancel, equals 9x ln x. That's number 6. Number 7. Find the derivative Use logarithmic differentiation. Y equals x. So y equals x times x plus 6 x squared plus 6x x squared plus 6x to the power 1/2. That's what square root means. Bring the power down. So take the derivative of the outside first. So subtract 1. That's negative 1/2. Times the derivative of the inside. 2x plus 6. So this whole thing, since it's a negative exponent, this is 1/2. 6x to the power positive 1/2 now. Since that's times, so it's 2x plus 6. We can factor out a 2, so we have x plus 3 on top. This is x squared plus 6x. And there we have it. That's our derivative. Alright, so that, let me write that down. Number 7. So it's square root of x squared plus 6x, all under x plus 3. Number 7. Number 8. We have some implicit differentiation here with exponents. Okay, I need some more room here. All right, number 8. 3, 8, 8. Was it 8? Yes. It says x to the 4y power, y to the 7x power. All right. Since the exponents are variables, we have to get rid of them. Not get rid of them, bring them back down. So we do that by taking the ln of both sides. What that does, that brings the exponents down. So we have 4y ln x, 7x equals ln y. And I take derivative of both sides implicitly. So this is a product rule. So we have 4y ln x. The derivative of 4y is 4 dy dx. Derivative of ln x is 1 over x. So 4 ln x dy dx plus 4y over x. That's this first part. Same thing on the other side. 7x ln y. Derivative of 7x is 7. Derivative of y is dy dx over y, which comes dy y dx. So it's 7 ln y plus 7x over y dy dx. Now I have to get all the dy dx's on one side, so I subtract 7xy dy dx from both sides. And subtract 4y over x from both sides. So we have 4 ln x dy dx minus 7xy dy dx equals 7 ln y minus 4y over x. We combine those two and those two. Factor out dy dx. I got 4 ln x minus 7x over y. Ln y over 1 minus 4y over x. Get a common denominator. In this case it's y, so it's, I can put a y here and a y there. X here, x there. So four y ln x minus 7x over y. 7x ln y minus 4y over x. Alright, so I have to multiply both sides by y, 4y ln x minus 7x. That's gone. So I have 7x ln y minus 4y over x times y, 4y ln x minus 7x, which makes it 7xy ln y minus 4y squared, 4xy ln x minus 7x squared. And there's the answer. Whew, a lot of work, but that's the answer. Put that on the answer sheet. 4xy ln x, 7x squared under 7xy ln y, 4y squared. I'll do the last two on this sheet. Number 9. Find the derivative of y. Yeah, I need some space here. Well, three, 8, 9. Y equals x 5 pi. Is it 5 pi? Yeah. Okay, so now we have to get a derivative of both sides. So it's an exponent. We can't take a derivative to an exponent, so we take the ln of both sides.